So in this video we'll talk about ladder friction. You all know what is ladder, right? It is used to climb a heighted surface like wall or roof. So suppose this is a ladder. Suppose this is a ladder where we keep our food. This is called rung. This thing is called rung. Suppose this ladder is resting on a, this is the floor and this is the wall. So when the person is climbing over it, suppose it is about to fall, then how it will fall? It will fall like this. So it will fall like this. So this top portion will go downward and this will move towards left. So how the frictional force will act? Suppose these are rough surfaces. So how the frictional force will act? Frictional force will act in the direction opposite to the direction of motion. So suppose this end is moving downward. So frictional force at this portion, that is at the wall, will be in the direction, in the upward direction. So suppose this is a frictional force wall, and here it is moved towards left. So how the frictional force will act? It will act towards right. So this is floor, so frictional force floor, FF floor, will be act towards right. And what are the other forces will act? One is the normal reaction. Normal reaction will act normal to the surface. So it is the reaction at wall, and here it is reaction at floor. So it is normal to the floor and it is normal to the wall. And also the weight of the ladder will act at its center of gravity. Suppose we assume it as a rectangular object, then weight will act at its middle. So these are the free body diagram of a ladder. These are the forces acting on a ladder. So next we'll solve problems related to ladder friction. So now the question is, a uniform ladder of length 3.25 meter and weight 250 Newton is placed against a smooth vertical wall with its lower end 1.25 meter from the wall. The coefficient of friction between the ladder and the floor is 0.3. What is the value of frictional force between ladder and floor, so that the ladder will remain equilibrium at this position? So we have to solve this. So question is, a uniform ladder of length 3.25 meter. So we'll first draw the diagram. Suppose uniform ladder, its length is 3.25 meter. So this length is 3.25 meter, and it is given that its weight is 250 Newton, placed against a smooth vertical wall. This wall is smooth, so no frictional force. And the coefficient of friction between ladder and floor, that is mu floor equal to 0.3, and it is given that its lower end is placed at a distance 1.25 meter from the wall. So from the wall, its lower end distance between the lower end and the wall is 1.25 meter. So these are given, and so it is asking what is the value of frictional force between the ladder and the floor. So it is asking frictional force at floor is how much, and it is asking that show that it will remain in equilibrium position. So to maintain equilibrium, what are the conditions? First we will check what are the force that will act. So here, because of the contact, there will be a normal reaction at the floor, and here there will be a normal reaction at the wall, and it will move downward. So frictional force will act in this direction. So frictional force will act towards right. So frictional force at floor, it will act in this direction, and this is normal reaction which is acting in the normal direction, and here it is the weight. So now all the forces are clear. So next we'll solve for the equilibrium condition. For the equilibrium condition, what will happen? So to keep it in equilibrium, we have to balance all the forces. So net horizontal force equal to 0, net vertical force equal to 0, and what are the other thing we need to keep to maintain this in equilibrium? Here all the forces are not concurrent, so there will some moment due to individual force. So to keep the body in equilibrium, we have to balance the moment also. So here, to keep the body in equilibrium, we have to balance the moment. So net moment equal to 0. These are the three conditions, essential conditions for equilibrium. So we'll solve this. So if we'll balance the horizontal force, then frictional force floor equal to normal reaction at the wall, and if we'll balance the vertical forces, this is the acting upward, this is weight is acting downward. So reaction at the floor equal to 250 Newton. Weight is also acting vertically downward, and this is normal to the surface, so this will balance this. So normal reaction is 250 Newton. So now we have to apply balance the net moment. So to balance the net moment, we have to find out this length. So this length is, suppose this is a triangle ABC. So what is BC? BC equal to AC square minus AB square root over, that is equal to root over of 3.25 square minus 1.25 square. So I'll check this answer. So I have calculated BC as 3 meter. So next we will calculate this theta value. So sin theta equal to 3 by 3.25, opposite by hypotenuse. So 3 by 3.25, so theta equal to sin inverse 3 by 3.25, that is 67.379 degree. So to calculate moment, we'll calculate this, we need to find out this distance. So if this is theta, this will be also theta. So the weight will act at its middle. So middle means this is 3.25 by 2, 1.625. So here to here 1.625 cos theta. So what is this value? That is 0.625 meter. From the triangle similarity also you can find out this distance. You can equate this triangle and this triangle, and you can find out this distance, because you know this distance, the total distance, and this distance, so you can find out this distance. So anyway, its value is 0.625 meter. So next we will apply the moment. So let calculate the, we need to find out this value, this frictional force value. So if we'll apply moment here, then moment will be 0 due to frictional force. So we need to calculate the moment here. So at this point, I'll solve it here only. So what is the this is the normal reaction, and how it is acting at this point. If this will try to rotate this ladder about this point, then how it will rotate? It will try to push it like this, so it will try to move it like this, so clockwise moment. So let us take this is positive. So RF into 1.25, that is the perpendicular distance between the moment center and this line of action of this force. And what is the direction of this moment? So it is acting how? It is acting at this point like this, so anti-clockwise direction, you can see. So frictional force is producing anti-clockwise moment, so minus frictional force into what is its distance, the perpendicular distance, will slide it its line of action along this. We know the transmissibility theorem, if we slide the force along its line of action, its effect will not change. So we can slide it along this, and the perpendicular distance between the line of action of frictional force at floor and the moment center is this distance, so that is 3 meter we have calculated. And what is the moment produced by this weight? How this weight is producing moment about this? See, so it will try to rotate about this, so also it is an anti-clockwise moment. So minus 250 into, what is this value? Minus 250 into 0.625, the perpendicular distance between weight and this moment center, this distance 0.625 meter. So that is equal to 0. Net moment equal to 0 to keep the body in equilibrium. So what is the value of RF? RF equal to 250. So I'll write it in the other side. So I'll write it here. So 250 into 1.25 minus 250 into 0.625 equal to frictional force at floor into 3. We'll take these two to one side and this frictional force to other side. So that implies 250 into 1.25 minus 250 into 0.625 equal to frictional force by 3. So we'll calculate the value of frictional force at floor. So 250 into 1.25 minus 250 into 0.625 equal to frictional force at floor into 3. So after solving this, we found the frictional force at floor which is required to keep the ladder in equilibrium position is 52.089 Newton. But what is the limiting value of frictional force? Actual frictional force acting at the floor, that is mu times normal reaction. From the Coulomb's law, you know this formula. So that is mu times normal reaction at floor. Normal reaction at floor you have calculated by balancing the vertical force, which is 250 Newton. So this frictional force at floor equal to mu times normal reaction at floor, that is 0.3 into 250 equal to 75 Newton. So the actual frictional force which is acting at the floor is 75 Newton, and the force required to keep the ladder in equilibrium, that is 52.08 Newton. So as this value is greater than the frictional force required to keep the body in equilibrium, so this ladder is at equilibrium position. So now you clear. Next we'll solve another problem related to this ladder friction.